Let's spend a little time going over the specific interior state of the buffer manager. So here's a picture of our buffer pool with some pages in the frames, but actually how is that stored in memory? Well, when the system is booted, when the database system starts up, it mallocs a big range of memory to serve as the buffer pool. And then it just thinks about that memory as being in page size units called frames. But it's really just one big malloc of, say, megabytes or even gigabytes of RAM at the beginning of the system. And it's going to use that extent of memory. It's a static object. It's not going to get bigger or smaller. It's going to stay the same size. But it's going to use the frames in there as buffer frames for pages on the disk. And then in addition, there's going to be some metadata or some information about the buffer pool that's kept in memory as well in a data structure that describes what's in the buffer pool right now. So this is a rather small array in memory, which we also malloc when the DBMS starts. And you can think of it as a little in-memory table. It's got frame IDs, page IDs, a dirty bit that says whether the page is dirty or not, and something called a pin count, which we'll talk about shortly. And we're going to keep this data structure indexed by the page ID so that you can do quick lookups in here and say, where is page 6, for example? And the answer would be page 6 is in frame ID 4. And that's how we go find the physical location in RAM of the page 6 from the disk. So here's a little illustration of the state of the buffer pool matching the picture below. So we're going to do these illustrations. They're a little easier to look at. As you can see in the picture below, every frame from 1 to 6 has a page in it. Those pages are not necessarily in order, which makes sense because things will go in and out of the buffer pool. One of the pages is dirty, page 2, which is why it has a red squiggle on it and why the second row in that table has a Y in the dirty column. And then 2 of these pages have pins in them. Page 2 has 1 pin and page 6 has 2 pins. And you can see that we're keeping track of that in the state in the table below. Okay, so when we draw a picture like this of our buffer pool, hopefully now you understand what's the information that we're keeping in memory that represents this picture.